In this video, you will learn about equations in two variables. Now up to this point, we've been working with equations in one variable. So equations with one variable will look something like this, where you have 3x minus 2 equals 4. We just have one variable. Or maybe 2 minus a equals 7. We have one variable because it's just one letter. Okay, or maybe even this, where we have x squared plus 6x plus 5 equals 0. This still only has one variable. It's just going to be x. So yes, you see it more than one time, but it only has one unique variable, and that is the letter x. So in this lesson, we're dealing with two variable equations, which might look something like this. 2x minus 5y equals 8, where we have both x and y in the same equation. Or maybe a times b equals 10, where a and b are two different variables. Or maybe a squared plus b squared equals 36, where we have a and b both in the same equation. Now, when working with one variable equations, such as 3x minus 2 equals 4, the solution is going to be a number. All right, just one number is your answer. All right, whereas for an equation with two variables, the solution will be two numbers, or a pair of numbers. For example, if you had 3x plus 4y equals 10 as your equation, negative 2 for x and 4 for y is a solution of the equation. Because if I put a negative 2 in for x and a 4 in for y, we would have 3 times negative 2 plus 4 times 4 equals 10, which is a true statement. Okay, that will make this statement or equation true. So negative 2 and 4 is a solution. When you write your solution, instead of writing it like this, where x equals negative 2 and y equals 4, we can write this as an ordered pair. So we see here, negative 2 comma 4 is how we would write that solution. All right, where negative 2, your x value, will come first, and then the 4, or your y value, will come second. So x comes first, y comes second, just like in the alphabet, right? X comes first in the alphabet, followed by y. Same thing when you write your ordered pair. X comes first, y comes second. So looking at the example where 3x plus y equals 1, we are to determine if these different ordered pairs are a solution to the equation. So to determine that, what I do is I plug these numbers in for x and y. So instead of 3 times x plus y, for the first ordered pair, we would have 3 times 1 plus negative 2, and that's equal to 1. So is this a true statement? Well, we'd have 3 plus negative 2, which is 1. So 1 equals 1. Yes, that is a true solution. Therefore, is a true statement. Therefore, this would be a solution. All right, so this one works. We have a solution. So then the next order pair, we plug that in to determine if this is a solution or not. So instead of 3 times x, we have 3 times 1. And instead of plus y, we have plus negative 4. So we have 3 plus negative 4, which is negative 1. So negative 1 equals 1. That is not a true statement. Therefore, 1 negative 4 is not a solution. And we could do this for 1, 0 and for 0, 1. So we plug a 1 in for x and a 0 for y. We have 3 times 1 plus 0 equals 1. That would be 3 plus 0, which is 3 on the left side. 3 is not equal to 1. That is a false statement. Therefore, 1, 0 is not a solution. One last time for 0, 1. We plug a 0 in for x and a 1 in for y. We now have 3 times 0 plus 1. And on the left side, that would be 0 plus 1, which is 1. So 1 equals 1. That is a true statement, therefore 0. Next we have a theorem that discusses what happens when you graph an equation in two variables. So if you have an equation written in the form ax plus by equals c, then it will form a line when graphed. So equations that look like this are called linear equations because they create a line. So for example, a, b, and c can be any number. So 2x plus 3y equals 4, for example, would be linear because a would be 2, b would be 3, and c is 4. So this equation, when graphed, would make a line. Now, a, b, and c could be fractions or negative or decimals or whatever. So here we have another example. Negative 4 over 3x plus 5y equals 9. This would also be linear because we have ax plus by equals c. Y equals 3x minus 1 would also be linear because we have something with the y, and then something with the x, and then a number. All right, so the number with the y would be a 1 in this case. And I can rearrange this to look more like the original format. So if I wanted to, I could bring the 3x to the left, and it would be negative 3x plus 1y equals negative 1. And that would look more like the other two types of equations that we had written right here. Next we have x equals 1. That would also be linear, and the reason is because there would be 0 y's. So for example, I can think of this as 1x plus 0y equals 1. So a, b, or c could also be 0. All right, so in this case, b would be 0, and then a would be 1. It's the number with the x term, and then c would be 1 as well. So that is also linear. If we had y equals x, this would also be linear because we can rearrange this to look in this format. We would have x minus y equals 0. We would bring the y over here. X minus y is 0. So x would be, or a would be 1, b would be negative 1, and c would be 0. Now, examples of not linear equations would be something like this. X times y equals 7. Notice in this format we need x and y being added together, and there could be something with the x and the y as well. Here x times y is not linear because it's being multiplied and not added together. 2x squared plus 3y equals 7 also is not linear because of this exponent. All right, that would make it what's called quadratic, and that would not be a line. That would be a parabola. If we had division, so like 3 divided by y, that is also not linear because notice right here, we need b times y. Something times y. We cannot have 3 divided by y. That is not linear. And this format, by the way, right here is called standard form. So if you have the x and y on the same side equaling a number, that is standard form. So in more specifics, some examples would be 3x minus 4y equals 6. We have x and y on the same side equaling the number on the right side. 2x plus 5y equals 10 would also be in standard form because we have x and y on the same side equaling a number. X equals 2 would also be standard form because there's 0 y's. So we can think of that as 0y plus x equals 2. That's standard form because x and y are on the same side. In this case, there is no y, but the number is on the other side. Same thing with y equals 4. There's 0 x's. So x and y are kind of on the same side, so to speak. And then the 4, the number is on the other side. Here are some examples of not standard form. First would be 1/3 x minus 2y plus 6. And the reason is because we cannot have fractions. So if you notice right here, as a little side note, a, b, and c must be integers. Integers would be numbers like 1, 2, 3, or -1, -2, -3. Numbers that are not fractions. So 1/3 would not make this standard because we cannot have fractions. Y equals 2x minus 4 also is not standard form, and the reason is because we need x and y on the same side. So that is not standard form. This is not standard form either because, once again, x and y are on both sides this time. We need it combined onto one side. So that would not be standard form as well. Now, working some more with these linear equations, we need a little review from geometry. So if you're trying to graph a line, how many points are needed to determine where a line will go? Well, the answer is going to be 2. We need 2 points to determine where a line will go. Right? If you had just 1 point right here, and you said draw a line through that point, well, it can be any number of lines, right? You could go like this, you could do this. There's an infinite number of lines you could create. So to know which direction it's going to go, we need a second point, and once we have the second point, now we know for sure, okay, hey, it's going to go through these 2 points, so it's got to go like this. And that's the only way to get that line. So when you're graphing linear equations, you need 2 points to graph. So what I can do is I can find any 2 points, it doesn't matter where. Okay, it's still going to be the same line, no matter where the points are. But we need to figure out 2 points that would make this statement true. So to find that, we can plug in numbers for x or for y. It doesn't matter which one, and it doesn't matter what number. But I'd recommend plugging zeros in because zeros will make things a lot easier. So for my first point, I can plug a 0 in for x and get 3 times 0 plus 2y equals 4, which would be 2y equals 4, so y would equal 2. So my first order pair would be 0, 2, and we can graph that right there. So we have 1 point. Now we just need one more point, and we can finish the line. So if we plug a 0 in for y for the second point, we would get 3x plus 2 times 0 equals 4. So 2 times 0 is 0. So I have 3x equals 4. Divide both sides by 3. So x would equal 4 over 3. So my order pair would be 4 over 3, 0. So to graph this, we have to know what 4/3 is. 4/3 would be 1 1/3. So that means for x, I go to the right 1 1/3. So I kind of estimate where it's going to be, and it's going to be somewhere around there. And 0 would be my y value, so it goes up and down 0. So I have my 2 points, 0, 2, and 4/3, 0. I connect the dots to make my line, which would look like this. So once again, we don't have to use zeros, but zeros typically are going to be easier to work with. Here's another example. We have 2x minus 3y equals -9. So to graph, I need 2 points. And again, usually zeros will be the easiest to work with. So let's plug a 0 for x for the first point. So here I'd have 2 times 0 minus 3y equals -9. 2 times 0 is 0. So I have 0 minus 3y, which is minus 3y. And that's equal to -9. And then to solve, I need to get rid of this -3, which is being multiplied. And I get rid of it by dividing. So divide both sides by -3. I have y on the left and +3 on the right. So when x is 0, y is +3. So my order pair is 0, 3. And to graph this, I go over 0 and up 3 to get this point right there. Now to find my second point, I can plug some other number in. And let's plug a 0 in for y this time. So now we have 2x minus 3 times 0 equals negative 9. 3 times 0 is 0, so I have 2x minus 0, which is 2x. So 2x equals negative 9. I can solve by dividing both sides by 2. Now I have x on the left and negative 9 over 2 on the right. So my ordered pair is going to be negative 9 over 2, comma 0. And negative 9 over 2 is the same thing as negative 4.5. So my point is negative 4.5, 0. So negative for the x value is going to go to the left. So that's going to be 4.5 to the left, which would be about right there, between 4 and 5. Now I have my 2 points. I can connect the dots, and I get this line right there. Now to finish off this lesson, we need to know how to graph lines that look like this, where we have 0x and then y equals something, or let's say we had 0 y's, so it's x equals something. Well, here we are working in 2 dimensions, so we have this coordinate plane we're graphing in. If it was in 1 dimension, it would be graphing on a number line, and it would just be a point on the number line. But here, since it's 2 dimensions, we need a line. So the best way to think of this is we need 2 points, right? So let's plug in values for x. Let's say x is equal to 0. When x is 0, what is y? Well, okay, y is 2. So there is no x though. But what that means is that y is 2 no matter what. So if x is 0, y is 2. If x is 1, y is 2. If x is 4, y is 2. So I have all these different ordered pairs, 0, 2, 1, 2, 4, 2, whatever. If I plot all of those, I'm going to get a horizontal line like this. 0, 2 would be right here, 1, 2 would be right here, 4, 2 would be over here. Okay, it doesn't matter, we're going to get this horizontal line. So y is 2 no matter what, and this is my graph. So if y is negative 1, it doesn't matter what x is, y will always be negative 1. So it's going to be a horizontal line like this here at negative 1, because on this line, y is always negative 1. X can be anything. Y will still be negative 1 on this line. Now what if you had x equaling something? Well, same concept. It doesn't matter what y is equal to, because y does not affect x in this case. X is 3 no matter what. So if y is negative 1, x is 3. If y is 0, x is 3. If y is 2, x is 3. So we have all these different points, 3, negative 1. We have 3, 0, 3, 2, etc. No matter what, x is 3. So if I were to try graphing some of these, x is 3, y is negative 1. That'd be right here at that point. 3, 0 is right here. 3, 2 is right here. Connect those dots, and I have a vertical line in this case that goes through all 3 of those points. So with this vertical line right here at 3, it doesn't matter what x is equal to. X can be anything, or sorry, y can be anything, but x will always be 3. Alright, it doesn't matter what y is equal to, x will always be 3. So if x were something different, maybe negative 2. So if x is negative 2, that means we have a vertical line at negative 2. So right here with this vertical line, y can be anything. Y can be 0, negative 8, y can be 100. It doesn't matter, x will always be negative 2, which makes this vertical line. And that concludes our lesson for today. We will see you next time.